We mentioned time as a dimension of spacetime and mentioned that spacetime is four-dimensional, three dimensions of space and one dimension of time. But isn't time something totally different than space? How can we compare something in time, which we measure in seconds or days, to something we measure in space, which uses kilometers or miles? And how can we just put the two together? Well, it turns out they're more similar than they appear. Much like we can measure a distance in space using kilometers, that same distance would appear to be different if we measured it using miles. We'd have different values for our results, and it wouldn't be clear that we measured the same thing. It turns out you can measure time not just in seconds or hours or days, but in meters or any other unit of distance. We are already somewhat familiar with this concept when we talk about light years, or distance that light travels in 1 year of time. What we've done in this case is converted the time measurement into a distance by a constant conversion factor, the speed of light. Oddly enough, one way to think about this is that we've always been measuring the passage of time inconsistently for historical reasons, and for human reasons to make it easier to work with time in our everyday lives. It is surprising to see that the speed of light is really just a constant to convert classical measurements of time into a more natural form for its presence as a dimension in space-time. Does that mean time and space are actually the same? Well, no, they're clearly different. Time moves forward in one direction, and it's always flowing in that direction. However, we can treat space and time on the same footing, where we can then make equivalent comparisons between the two as contributing dimensions in space-time.